So you want to do yet another hypothesis test. We have a situation that last year the average time spent on social media in the USA per day was 144 minutes. This year, a random sample of 66 Americans, so we're taking a random sample of 66 Americans, they spent an average of 157 minutes on social media per day. Now, we're told to assume that the standard deviation in minutes per day on social media for all Americans, not the sample, but all Americans this year, is 28 minutes. Use the 0.05, that's the 5% significance level, to test the claim that this year's social media usage is the same as last year's social media usage. All right, so we want to do a hypothesis test. So let's do step 1. We want to identify the null and alternative hypothesis. Okay, so we're going to write H0, right? That's the null with the colon, and then H1, that's the alternative with the colon. Now, these are going to be about mean or average of the population, so we're going to put mu there for each of these. Now, remember, the null hypothesis, H0, that involves always the equal sign, always. So what are we comparing this to? Well, let's read. What are we testing? What are we supposed to test? We're supposed to test the claim that this year's social media usage is the same as last year's. The same as last year's. Well, if you read the very first sentence, last year it was, 144 minutes. So we're trying to test that this year's is the same as last year's. So the mean is equal to 144 minutes. So last year's was 144. So we're testing the claim that it's the same as 144, right? So that's the claim right here we're trying to test. Yeah, the claim is the mean is the same as 144 last year's. So when the null hypothesis and the claim agree, when you have the claim being equal to, the alternative is going to be not equal to. So we're going to say not equal to 144 is the alternative. Remember, again, that alternative has 3 possibilities. It could be less than, it could be greater than, it could be not equal to. We got not equal to here. All right, so we're done the first step. Step 2. We're going to find the critical values. First thing we want to figure out here, are we using the Z distribution or the T distribution? Z distribution or the T distribution? Z or T distribution. Well, if you read carefully, when it talks about the standard deviation, that's talking about the population standard deviation, right? It says assume the standard deviation in minutes per day on social media for all Americans. So when it's not talking about just a sample of 66 Americans, it's talking about the population of all Americans. We have population standard deviation is given, right? This is given to be 28. So since we have population standard deviation, we're going to use Z distribution. Z distribution, let me write that. Holy mackerel. So when you have sigma, population standard deviation, you're going to use a Z distribution. All right, next question is how many tails? You're going to do a left tail, a right tail, or a two-tail. Well, notice when your alternative here, what's our alternative? Our alternative is not equal to. So we're going to do two tails, right? Two tails test. Well, what was that? Why did that do that? I don't know. Strange. All right, two tails test. Now let's draw a little picture. Here's my z distribution. I'm going to have 0 in the center. I'm going to have a tail on the left, a tail on the right, because we got two tails. And let's say in those two tails, we got a little bit of shading here. Here's the left tail, here's the right tail. And the significance level, that's the probability of making an error, 5%. So 5% is in both of those tails. No, come on now. So split up between those two tails is what's called alpha, 5%, 0.05, right? Now, we want to just focus on the left tail right here. So just focus on the left tail. Take alpha divided by 2, right? Because there are two tails. So just the left tail is going to be alpha divided by 2. If we take 0.05 divided by 2, we're going to get 0.025. And that's just in the left tail here. Now, I'm going to have two z-scores. I'm going to have a z lower star right here. I'm going to have a z upper star up here. The first thing I want to do, I want to find the z lower star. Once I find that, I can easily find the z upper star. So to find z lower star, we're going to go to our z table and look up 0.025 in the middle, right? The areas are in the middle, so let's do that. So where's my t table? I'm sorry, my z table. 0.025. So 0.025, if you look very carefully, right here, right, in the middle, that's where the areas are. 0.025. That's going to give me a z-score of, look on the left, negative 1.9 and above 0.6, and negative 1.96. Negative 1.96. So once I have my negative z-score, the positive z-score is just going to be on the opposite side, right? So it'd be a positive 1.96. I got my two z-scores, my two critical values. All right, so step 3. That was the hard part, step 1, step 2. Step 3. Compute the value of this test statistic. So step 3, compute the test statistic value. So we're dealing with z's, right? Our formula is x bar minus mu divided by sigma over the square root of n. So what was my sample size? No, wrong color. So how big of a sample did we take? What was the sample average? What was the population standard deviation? What are we going to assume that the population mean is for the sake of argument? Those things we have to find. All right, let's go back and read carefully. Looks like I took a sample of size 66. Like this year, a random sample of 66 Americans. That's going to be your n, right? 66. What was the average of that sample? A random sample of 66 Americans spent an average of 157 minutes on social media. So the sample average was 157. What's the population standard deviation assumed to be? Here we're told to assume that for all Americans, it's 28 minutes on social media. So sigma is 28. And then for the sake of argument, come on now. For the sake of argument, we're going to assume that the population mean here is equal to 144. So no, that was not what it was supposed to do. Not the right thing to do, man. You're not the right thing to do. So we're assuming that the mean here, the mean is 144 for the sake of argument. That's called the null hypothesis. So you assume the null hypothesis for the sake of argument. 144, the same as last year. All right, now we're going to plug all this in to get our test statistic value. Come on. We're going to have, what, 157 minus 144 divided by 28 divided by square root of 66. It's going to be, what, 13 on top, and on bottom we're going to have parentheses, 28 over square root of 166. So make sure when you plug in, you do 13 divided by parentheses, 28 divided by square root of 66, close parentheses, and the enter button, and blah, 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 blah. You should get 3.77. Take it to 2 decimal places when you round it. All right, so I got the third step. That's pretty straightforward, just doing that computation. So what color are we using next? We'll use blue. Step 4, we have to make a decision about the null hypothesis. Make decision about H0. H0 is called the null hypothesis. So I'm going to draw a little picture here of my Z distribution. That's what we've been working with. Got 0 in the center. I got 2 tails. 2 tails, right? Got a right tail, I got a left tail. I got 2 critical values that we found. 2 critical values. We had a Z lower star, which maybe you remember, Z lower star was negative 1.96. And Z upper star was positive 1.96. And our critical value, Z, representing the sample information, is what? 3.77. If you think about where 3.77 lands, it ends up here in the critical region, right? It's way above 1.96. Yeah, somewhere way up there. That pink region. So it's definitely in a rejection region here. So we're going to reject the null hypothesis. Reject the null hypothesis, since the test statistic is in the rejection region to the right of 1.96 here. Okay. So all we have to do is finalize this by summarizing our conclusion. Step 5. Summarize conclusion. So to get the wording correct on that, what you can do here, you can use this little document, our wording sheet. It's called hypothesis test. Wording of final conclusion. So did the claim that we're testing, does the original claim contain the condition of equality? And the answer was yes. Or if you go back and you looked at the claim right here, it was what? We're trying to test that the mean is the same as last year's. In other words, the mean is 144. So that's the claim we're trying to test. So it involves equality, right? Involves equality. So to answer that first question, does the original claim contain the condition of equality? We're going to say, yes, it does. Did we reject the null hypothesis? Yes, we rejected the null hypothesis. So we're going to say there is sufficient evidence to warrant rejection of the claim that, so let's write that, there is sufficient evidence to warrant rejection of the claim that. And you just fill in what was the claim. What was the claim? Remember what the claim that we're testing was. That the average social media this year was the same as last year. That the average social media usage this year was the same as last year's social media usage. Yep, so there is sufficient evidence to warrant rejection of the claim. So rejecting the claim that this year's was the same as last year's. Okay, so yeah, there's a two-tailed Z hypothesis test for population mean.